isn't it? I think on the first week or second week, right? Yes, okay, good. Johnny. Yes, Papa. Eating sugar, Johnny, today? No. Okay. Oh, no. Or telling lie? No. All right. So your project is consume about 40%, all right, of your mark, right, which is the individual project. So what you need to do is you need to develop an instrumentation system, right? So this is very, very important. Instrumentation system that can measure the light intensity. So light intensity in term of the illumination, okay, in term of lux, Lux, okay. And then you need to calibrate the proposed instrumentation, and then you test the instrumentation on your useful application. So useful application, that's mean any application that have a light. All right. So anything that you can create, okay, you can create the introduction, okay, about what you're going to do, what you're going to apply, what you're going to measure the light, okay. And then after that you investigate the accuracy. So when we talk about calibration and also the accuracy, that's mean you need to compare with something instrumentation, right? So for example, that you need to have the lux meter, right? So you can install it in your phone, right? There are many apps that are available for measure the light intensity. I think I have mentioned you before. Okay, and then you also been divided into a group, right? So a group is very important where you have some meeting with each other. So each member of your group can help you in order to share, in order to share, or in order to give to borrow some secret for you in order to get the result and so on. But you have to have in a group. So I have share you the link. All right. This one. So hopefully you can fill in your member of the group. Just put it the number of the group, right? One or two and so on. Okay. So that after that I will sort it, right, to each group. Okay. All right. This is done. I hope this is very clear. Okay. Uh, the second part is um, so your instrumentation system need to have all typical components like transducer. So in this case, we use the LDR. And then you also need to have some signal conditioning like OM, right? It's not just a simple, you just put it one resistor and then you get the result. No, if you do that, so that's mean it will be less mark. Okay. And then after that you need to have some display, maybe in term of, if you use the multimeter you can show, okay, this is the value that you get it. So if you want to make it an advance a little bit, so you can put it in the LCD panel, or you can put it using the Arduino and display it in the serial monitor. Okay. All right. And like I mentioned before, so you need to choose a useful application. All right. And then the application of the project that you choose need to be different with others member. Okay. Right. This is a most important thing. And then you can develop whether it's a lock meter, right? It's an alarm system, right? Maybe you set it at a certain level, it can make some alarm, okay? Something like that. And about the material selection, so you can develop a casing little bit, right? Maybe in terms of that. So just put it in your report, okay? Sensor calibration chart and graph. Okay, this is what I mentioned you before. you need to have the comparison between the others lux meter, right? So the simplest one, you can use the apps, right? The lux meter app, okay? And then you start to measure the system accuracy, okay? All right. Any questions so far, guys? So I believe this is the second time, right? For the project briefing. Any question? Johnny, do you have any question? Okay. No. Okay. All right. Okay, for the assessment, you need to come out with a video, very short video, all right, about the introduction, okay, about your project and so on. So how you design your system and functionality, whether it work or not. Yes, Daryl John, yeah. Doctor, do we need any physical equipment for this project? Yes, sure. This is the project you need to have the physical. You need to buy the components, right? This is the project. Can we have a report example? All right. I think I will provide it for you. Okay. So last time I have shared it, but I forgot it. I put it one. Okay. So please remind me that. Okay, Hazim, please remind me that. Example tells example project. Okay. Okay. Please remind me that about that one. I think this one. Okay. 38. Yeah, but this one is not a good example. I have a very, very good one, I think. Okay. This one is not a good example. Where is it? Yeah, the report is something like this one lah. So you can have a casing little bit and the circuit, all right, and calibration and some reference. I think yes. This is what I want, right? You just show, maybe you can act a little bit, right? And then you ask your friend to get the picture from you. So this guy, maybe your senior, have done a lot, right? And I don't know, it's a very dangerous, right? But he showed a good effort, right? Okay, now get my picture, right? Wow, he do some spray. Wow, he put a lot of effort. Wow. Okay, Hazim, something like this, right? Boleh Hazim? Okay, boleh ya? Yeah, this one is very good. You can get it 38. Okay. All right. Done. Report done. This is the rubric. So some of you asked about the rubric. The chapter 2 mechanical design is about on how you design by using the SolidWorks, right? And also you fabricate in terms of the casing and so on. So this is chapter 5, system accuracy. All right. So I also provide you the list of the components. So this is the recommendation, right? You can buy all these things, or maybe you can choose So which component that you going to buy, okay, right? And there is some of the optional component if you want to use the Arduino, right, or so on, to display the result, okay. But more important thing is the multimeter. So you need this one multimeter, all right. So maybe after this you need it for the others courses, right? Maybe for your FYP and so on. Okay, so this is the optional, or we call it recommended. Okay, so fine. All right, so let's go for the Tinkercad. All right, Tinkercad. So uh, Tinkercad. So Tinkercad. So for those who's not familiar with the Tinkercad, so here is the time you to get it familiar. Okay, so first of all, when you want to log in to the Tinkercad, you need to create the join now, and then you can create the sign in. I think, yeah, sign in with Google. Yes, you also can have it like email, right? Okay, done, and then you can create the circuit. Okay, so in this case, I have a lot of circuit. Okay, so let's go one by one. Okay, um, very quick one. Wait a minute. What is it? Open new Windows. Okay, create a new circuit. Any question that you have in your mind, you can type in the chat. Okay. All right. So this is the Tinkercad. So you can click for the all components, right? There are a lot of components like in the general, the resistor component, button. Yeah, we also have the photoresistor, which is the LDR here. And also you have a lot of things, sensor, LED. Um, we also had the power, right? You can power from battery, 1.5, and breadboard. Okay, breadboard is very important. And we have the multimeter, power supply, and also the more important thing about the OM. Where is it? OM. Yeah, OM 741. Where are you? Okay, this one, OM. Okay, so let's look a little bit. So the first of all is the breadboard, right? Okay, so you can my suggestion, try to buy this kind of the breadboard, right? We have it's not the shortest one. Okay, try to find this one. All right, and what is it? So you can have very basic resistor. So this one by default is 1K. And then the more important thing when you play with the electronic, so you need to have the multimeter, right? So for example, to measure the resistance, so you can click here, and then you can click and click here, and you can start simulation. So it can show you this value for the resistor, right? These are very basic. And you also can have the power supply. So you can set 5 volt, or you can have the battery 9 volt. Okay, here. All right. So you can have another multimeter for this simulation. Okay. So if you want to highlight all, you need to press the shift, and then you can select all, right? Shift and select all. And if you want to change the polarity, so you can mirror this one. If you change polarity, you can measure it. Okay, these are very basic lah. Okay. Oh, why is error, guys? Oh, because this measure resistor, right? Voltage. Okay, done. All right, and let's look about the LDR a little bit, right? So this is the LDR, and you also can have another multimeter. Just copy. So for the LDR, right? LDR is actually the output will be resistor, right? Okay. So when you want to buy the LDR, so you need to look at the maximum resistor. Okay. In this case, it have 180 kilo ohm. 180 kilo ohm where there is no light. Okay, there is no light that's mean in the dark. All right, in the dark. And then when you have the light, so from the 80 from the 180 kilo ohm, it go down to 500 ohm. Okay, this is a very very important, right? When there is no light, right? There will be 180, and then after that it will be 500 ohms. Okay, the maximum one. All right. So you need to choose when you want to buy the LDR, right? Any question? Do you have any question right now about the Tinkercad? You
No, doctor.
no, doctor. Okay, everything clear? Good.
Still
Right.
processing.
Okay. So, when you want to search about the LDR, so it will show you Shopee, right? LDR. So there are a lot of things. It's a very cheapest one. This is the LDR 10K to 20K. I think you need to choose which one that you want to buy, right? Okay. Right. And more importantly, this one lah. Alright. This is what 10 pieces. You need to look at only keep 10K to 20K. Okay. The light resistant maybe in the dark maybe is 10K, right? In the light maybe 20. Oh, maybe in the dark is 20K. Maybe in the light will be 10K, I think. Okay. All right. So resistor done. Okay. The next is the potential meter, right? Potential meter. When you search in the Shopee, now is everything in the Shopee, right? You want to buy the software crack, you can go to the Shopee also, right? Okay. So there are a lot of the potential meter, uh, like this one, right? The very big potential meter, and also you can have the multi-turn, right? So for the very sensitive potential meter, so try to choose this like this one. They will be a very good right, a potential meter. When you try to turn this one, right, turn this knob, it will give you very accurate value. Compare with this one. Compare with this one. This one is a very difficult to adjust. Very very small value. All right. So try to use this one. We call it multi-turn, right? Multi-turn potential meter. There are a lot. So not this one, right? This one is not good. So it's kind like the multi-turn, call it. Okay. All right. So there's the potential meter. So you also can have the potential meter in order to measure. So for example, you want to set the resistor here and some and run the simulation. So you can adjust it. Okay, 250K because the maximum we set it is 250K. So the potentiometer is a very good, right, for you to choose to control the resistor value. And then the rest is the LED, right? You want to build the alarm system and also the buzzer, okay? So you can put it the voltage like here, for example. Let me show you. Some, 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 some. Let's play. Okay. Right. So this is a very basic one. Okay, so now let's move to another one. Basic component was 01. Let's move to 02. Okay, voltage divider. So 01, the basic component done. Okay. Now we create a new circuit for the voltage divider. Alright, so is for all components to choose. Where is it? The breadboard done. Okay, so now let's do the some very basic voltage divider, right? Okay. What's other you need? Multimeter I need it. And then I need the LDR. Yes, I need the LDR. Okay. And then what you needed? I need a resistor. Okay. I do the voltage divider, right? Okay. This one we set it here. Okay. If you buy a very long breadboard, right? So there will be some what we call it, some gap here, right? So you need to put it the jumper here, right? So that all the line will be go through this. So for the breadboard, all this line is shorted, right? Okay, except this one you need to put the jumper, right? And this one, all this one is shorted, but this one and this one is not shorted. And this one to this one is shorted, right? But this one and this one is not shorted. Okay, all right. So done. So let's do very basic voltage divider. Okay, 5 volt going to the LDR, and we going this one, put it here, right? The ground. This one we put it the ground, and this one we put it here. And we want to have the multimeter here. So some of the multimeter. So the black one, we put it in the ground, we mention here. So you also can have other multimeter, right? Okay, just to measure this one. Okay. Alright, this is very, very basic. Okay. So this is a very basic circuit for the LDR. You just put it the resistor and so on. So when you adjust the light, right, of the LDR, so you will see that. Okay, will be from the dark, you can get it here. But of course, this one is very, very basic, right? This one is not an instrumentation system, although that you can only put one resistor, but I believe the sensitivity of the LDR is not good, right? So that's why you need to combine it with the Western bridge, okay, in order to get a very good sensitivity, right? By the way, this is very basic lah, okay? All right. Any question that you want to ask? Any question?
Doktor, display tu macam mana pula?
Display, if you want to have a very simplest display, so you can you can display your value on the multimeter. That's it. And then you record your value and then you put it into the table. Alright? Boleh. The display is, right, like I mentioned before, the displays can be multimeter, can be LCD panel. That means if you want to display your value to the LCD panel, that means you need to use a microcontroller. You need to use the Arduino, for example, right? Or if you want to display on the serial monitor of the Arduino, so that means you need to use also the Arduino, right? Boleh. The Arduino, have you learned about the Arduino before? Yes, right? I believe. So this one, right? The serial monitor. Okay. So you can display the value on this one. So you can capture it. Just show the example, right? How you get the value. Okay. So if you want to have a very basic display, you can show on the multimeter. Yeah, this is the instrumentation that I have developed. Okay? Boleh? Boleh, ya? Okay. Alright. Now, done. So let's create the Western Bridge. Alright, the Western Bridge, a very basic one. Okay, this leave it there, there, there. Okay, alright. So there's a very basic one. So what you need? We need very two resistor. Okay, so I make it 180, right? Because after that I'm going to use the LDR. Here, remember the Western Bridge, it have like this, right? Okay. Right, this one and this one is going to ground. This one going to ground. Okay, and this one you going to 5 volt. This one you going to 5 volt. Okay, and you're going to measure between this, right? Okay. Okay, the other one is point A and point B, right? Okay, like this. Okay, when I run the simulation, so I got it 0, right? Because the all bridge is balanced. Okay, all bridge is balanced. So if I change the value a little bit, I put it only 1K, right? So you can see that. Okay, this is the value, right? 6.91 millivolt. So you can calculate by yourself, right? Okay, 1K divided with 180, right, equal to delta V over V, right, over 5 volt. So that's mean sorry, we can put it 1K divided with 180, okay, time with 5. So the value, oh, sorry, 1K divided with 180K divided with 4. Then you time with 5. 6.94 millivolt, something like that. I still remember, right? The formula for the Western Bridge, delta R over R divided with 4 equal to delta V divided with V in. In this case, our V in is 5 volt. Okay. Delta R in this case is 1K. Okay. 1 kilo ohm. R is all is 180, 180, 180K. Right? Alright. Familiar, right? Western Bridge. Okay. Done. So beside of we use the fixed resistor, we also can have a potentiometer here. Okay, let me show you this one. Okay, so now we put it back 180. Done. Down and down. Okay. All right. We can adjust the maximum one is 180. Okay. Or we can have just the multimeter lah. So this is the simulation, but it's a good thing for you to do in the Tinkercad first before you can proceed in the real hardware, right? Okay. Resistance here. Oh, when you want to measure the resistance, so you need to, yeah. So try to, what we call it, to turn off the supply first, okay? All right, if you want to measure the resistance. If not, it will be a little bit error. Okay, done. So if the maximum one is 180, right? So you can adjust it, okay? And if I change it to 5 kilo ohm, so this is like your IDR, your sensor, right? So it have increased about 5 kilo ohm. So this is the value, 34.2 millivolt. Okay. All right. So this is the very basic one. So if you want to make it balance, so you need to adjust so that you can get it zero. Adjust the value for the potential meter. For example, this one 5 kilo ohm, 105 kilo ohm. So now it becomes zero, right? So that means your value right now is a balance. Then you can start to do some measurement. Okay. So this is the purpose by having a potential meter on this bridge, right? To make the value is balanced, is a zero, right? So adjust the offset, right? And then you can make the measurement. But of course, the value, the increment of the sensor, for example, is 190, about 10 kilo ohm, and then the value is very small, 33.3 millivolt. Okay, and that's why maybe you need some OM after this, right, to increase the what we call it the value. Okay, all right. Okay, so this is about the Western Bridge done. So this is one done, Western Bridge. Okay, very basic one. Western Bridge, right? Okay, done. So next one is when you want to combine with the LDR. So let's do very basic one. LDR. Western Bridge number 4. 4. Western Bridge for LDR. Okay. Right. The bridge mainland. Okay. So let's combine with the LDR, right? So this is your LDR. Okay. So let's replace this one. Okay. Okay. Put it there. And then you just need it. Where is it? This one, right? Okay. Down. Put here. Done. Oh. Here and here. Okay, done. Run. Before that, we said the maximum one is 180. Okay. Now, why I got it 2.16? What happened here, guys? Okay. Anything. The bridge. Okay. This is. Did it, 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 did it. 69 minus 69 and increase it, so 2.5 will be minus, wait a minute, 2.5, 2.5, 2.5, 69. Yeah, it's almost zero, right? Sixty-nine. Yeah, oh, sorry. I'm not connected this one. Yeah, 69. Okay, so next one. So let's measure this one first. Oh, 1 multimeter for measured at this point. And second multimeter we measured at this point. 1 and 2. Okay. Two point five minus with 2.57, 0.07. Okay. Oh, that's why the value is okay, I know. All right. So there will be some value, right? Okay. So right now I set it potentiometer is 180 kilo ohm. Okay, 180 kilo ohm. So the maximum one, right? When I put it the maximum one, so you will got it actually the zero lah. 2.5 minus 2.5, right? This point minus this point is zero. So can you get it, guys? Do you have any question? So when you adjust is the multimeter, right? Okay. Sorry, the LDR. So the value that you got it is 2.5 minus 20.5. Okay. So try to put another multimeter. This is for you to understand it, right? Okay, so try to put it some. Yes, this one. Okay, some. This one. Okay, 2.5, 2.5, 0. Okay, it's almost 0. So 22.5 minus 22.9 milli. Yeah. I Is it clear for you guys for this one? Because the Western bridge is point A minus with point B, right? Okay, so that's why I measured two value here using the two multimeter. So at this point A, you got it 2.5. At this point B, you got it 22.9. Okay, 22.9. So why it got a minus 2.47? I think it used this point, right? This point is minus with 2.5. Okay, so you can check it. 22.9 millivolt, you minus with 2.5. So you will got it is minus 2.47. Is it okay, guys? Can you get it? Okay, all right. Right. So when the increment of the value, all right, from the dark, so the dark is about minus 2.15 millivolt, which is almost zero lah. So when it's increase, you see, the value will be uh, very small actually, okay, but you need to increase it by using the OM into this, okay. All right. So what I put the two multimeter here just to prove it, the point A minus with point B. So remember the Western bridge, VA minus VB. Okay. All right. So this is the Western bridge. Right. Any question? No. Okay. The next one, so let's move to the OM, right? Okay, number 5. Okay, OM. Okay. Okay, so we create a new circuit. This one, number 5, OM. OM. Okay, OM. Okay. So what you need? I need all. I need the breadboard. Give me the breadboard. Okay, done. And then I need the OM. Okay, done. This is my OM. And the OM, it need a negative and positive supply, right? Negative voltage, for example. So how to make the negative voltage? So you can combine it between these two battery, right? So positive, negative, positive, negative. So the ground will be in between this one. Okay. So let me make it right. Suppose I have a two power supply here, and then I have a two supply here. So how to make it negative voltage? Put it here, okay, and then this is positive value, and this one will be the negative value, and this one will be the ground, okay, right? So if you want to check it, you can do like this. So the ground one is connected to this one, and this one is connected to this one. So this one you will got it positive, right? Positive 5 volt. So you want to measure the negative. So you can put it here and put it here. This one you got it negative 5 volt. Okay? Boleh guys? Because the OM you need a negative supply, right? So 741 image. Yeah, I say for negative. Okay, when you use negative voltage. Okay, done. Let's move on. Okay, so now the positive one at pin number 7. Okay, positive one at pin number 7. This is 1, 2, 3, 4, 5, 6, 7. Okay, the power positive. Okay, done. And then the negative one, negative power, so we can put it here. Uh, okay, here. Okay, done. Positive power and negative powers done. Let's do the one resistor. I need a one resistor. Make it K1K. So one resistor go into minus, right? This one, right? Minus. And another resistor is going to the output. Also with this one, but it going to output here. So you just need a jumper here, and this one you need output here. Okay. All right. So then let's have a potentiometer. Right. So let's divider. Change the divider. Uh, okay. So let's power up this one. Okay. And this one going to this, and this one going to ground. So we need ground here. Put it here. So this one going to ground. Okay. Done. And this one you need some sound. Right. So let's have a multimeter to measure the voltage divider. This one the ground, and this one here. Okay. And then another multimeter to measure the output. Ground. Sound. All right. Okay. For example, my value is 62.6. Okay. So what happened, guys? Okay. So this one we need to the ground, right? For the inverting. Can you get it? So the gain. So how much the gain that I set it, guys? How much the gain? You? How much the gain? This is 1K and this is 1K, right? Isn't it? So the gain will be 1. Okay. So the voltage that you got it is minus because this is the inverting. Okay. This is the inverting. So that's why you got it minus. So if you want to change the gain, so you can change it like say I put it 2K. So the gain will be 2. So that's why 28.9 when you time with 2. So you got it about 57.8. Okay. Is it clear, guys? Any question about the inverting? Clear. Okay, good. Wow. Okay, good. And then let's combine between your yes. So now let's make the differential, right? So differential of m. differential OM. Okay, so OM differential. The differential OM, what you need is you need, let's I make it is 1K first. So this one be in. So this one going to this, and the feedback, and another one. Okay, the one you need one resistor going to this. Okay, and another resistor, pump. Okay, going to this. Make it like this, make it like this. Okay, and then the OM, right? This one going to ground, done. This one, yeah, the input. Um, let's say I need another one. Shorted bus. This one bounces. This one, yes, first done. And this one, I'm going to put it here. Here. Okay. Let's measure this one to here. Then you need to have some jumper here. Okay, done. Okay, so let's do some very basic OM, right? V2, everything is 1. So V2, 5 foot. 5 foot, the maximum. How to do the OM, guys? This is the V in 1, right? Okay, the V in 1. You go to this, the output. Okay, is the output. This is V2 5 foot. Here is also going to the output. Okay, so let's do. Hmm. Mm-hmm. 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 Wait a minute. Mm-hmm. Uh, can somebody tell me what's wrong with this? Uh, this one going to this correctly. All is 1K, right? So this one going to this output done. And we don't need all this thing. Going to this. Uh, we should get about 300 minus 562, 38. Yeah, I should get a 38 here. So why? Uh-huh. What? This is 1K, 1K, 1K. All is 1K, right? 1K, done. Okay. Hmm. Guys, anything that you can help me this one? I don't know, doctor. Power minus is going to ground, done. This one, we got it 600. Okay, done. This one, we got it going to this. I try to make the differential, right? V in, sound. And the other one is going to ground, right? Okay, ground. Uh-huh. This one is the feedback resistor, right? So the gain will be 1, right? Times 600. Hmm. It's the same thing, right? Hmm. Pelik ni, pelik. Why? Why? Okay. Uh, Let me show you this because we don't have time. All right. So this one I doing the differential OM. So if you look at this, so differential OM that's mean if this one is V2, this one is V1. So 293 you minus with 604, you got it is 311. You know what I mean, right? The differential. Okay. So when you adjust it, this one like 732, 732, you got it at 22.7 millivolt. Okay. So this is the differential. And I don't know why this one is not work. Okay. Why? It should work, I think. But right now it's not work. I don't know why. I need to check it back. So why it doesn't work. Okay. It should work. All right. So this is the differential. So why you need to have the differential? Because when you want to have the LDR, right, the Western Bridge, so you need to combine it with the differential. Okay, like this. Okay. So you have the LDR, so you combine it the differential OM in order to get the value. Okay, all right. Okay, uh, like this one. Okay, mhm. Go away. This one with the output. We stop it. Sorry, guys. So try to design it. This one. Yeah. So something like this. Okay. So when you increase it, 43.7 minus with 70.7, you got it about 27, right? Okay. Let me put it is 1K. All is 1K. 1K. So this one is 1K. So when you run it, so you got it 2.5. Okay. 2.5. All is 2.5. So this one is 70.7. So you minus with 43.7. So you got it about 27. Now what you got it is 16.7. 1. Something wrong there. Okay. It should be around 27, right, guys? Okay. Why I cannot get it? Okay, 5.8, 38, 37. 1K, this is 1K, this is 1K2, this is 1K. You should get, I think, you should get it is 27, 2.5. Why? Alright, guys, I think you can try first. Play around with this one. I believe the circuit will be correct, but I cannot find the error, guys. But I think you can try it first. So maybe if this one is not work, so you need to have some voted follower. I think maybe. Okay. So because we don't have much time for today, hopefully you can get it on how to construct the circuit from the basic LDR, from the voltage divider. So you construct the Western bridge, and then from the Western bridge you also construct the OM, very basic OM inverting, and then from that one you construct the differential, okay, differential OM, and then after that you combine it with the LDR and with the Western bridge and also the differential OM, right? I'm so sorry because the differential OM is not work right? For today. I don't know why. I need to find out why. Okay. Is it okay, guys? But I hope that you can understand it, right? The basic OM. Okay. The basic circuit using the Tinkercad. So if this one is work, that means you can construct your circuit on the hardware. You can buy all these components and so on. But of course you don't have the power supply, for example, so you can have the 9-volt battery, or maybe the AA battery 1.5. You can combine to have 4 battery and 3 battery and so on. Okay. Do you have any question, guys? Any question? Is it everything clear? And any question you're going to ask? I don't know why this differential is not work.
Doctor, I have a question.
Yes. Who's that? Zuhair, okay.
Saya nak tanya yang untuk projek ni, kalau katakan contoh dalam pula dia kalau kata dia dalam contoh dalam yang kelas kita ni ada lebih kurang 5 orang yang buat ada 5 orang yang buat lux meter. Dia
Ah.
maksudnya dia boleh ke sama ataupun just kena lain ke application je ke?
Okay, dia okay. I will uh, uh, okay. So I speak in English. Okay. So you can have a same circuit design. You can have the same circuit design like this one. Okay. But your application so need to be different. So on what you are developing right now is we call it is log meter, okay? But on how you going to apply for of your log meter to different application? Yeah, of course. So in our class we have about 27 student, right? So maybe your project and with others student will be the same, will be the application will be the same, but the difference is maybe in term of your report. So if your report is too detailed and concise, and also the result I think will be quite different lah, right? So of course you cannot have the same value amount of your friend, but the circuit I think will be the same, right? But the casing and so on, you design about your casing and also the mechanical and so on, and also you fabricate the casing and so on. I think will be different lah. Okay, is it I answer your question, Zuhair?
Satu. Thank you.
Okay, right, good. The circuit can be the same, so that's why you have been grouped in one group to discuss, to share, to borrow. But your application will be different lah, right? Okay, so I will mark based on the video, based on the report that you have sent it to me. So I just mark through on that. Okay, I will see the video, okay, about your explanation, about your animation and so on in your video. So you can get 10 mark. And about the report, so the chapter 1 is detail, so you can show about the in terms of the theoretical about the LDR, what is it, what is the application, what is the very important and so on. Okay, so the detail of your report, the detail, the mark that you will get. Okay, good questions you have. Anyone, do you have any question?